Okay. So let's clear the decks here a little bit. Okay, so you're looking at two pictures, two possible Lewis structures for the phosphate ion. I'm looking at one in which they've indicated a double bond, the other in which they have not. Now, if you were asked to justify this with formal charges, I would say probably the better of the two would be the one on the left, because again the phosphorus has the 5 that it's, at least it's up to 5 out of 5 that it should have, because on the periodic table, let's just wake one up. If we look at phosphorus under nitrogen, phosphorus should have 5 and does have 5 with the layout that we have over here, whereas here phosphorus has 4 and all of these 4 are -1. So of the two, I would prefer diagram 1 to diagram 2 if they asked me to explain it. Now the interesting thing is for letter H, it's almost a gimme, because they tell you the bond length of a single and they tell you the bond length of a double. And in this case, obviously, if the student finds all the bonds, now how they would find, irrelevant to our purposes. Hey Avery. Okay, apologies. I've just been told that this is blurry. Has that improved any? Because mine is crystal clear and what I'm seeing on the images is clear. Colin, has that improved any? Because I think what happened is when it first focused on a PDF, it takes a minute or two to resolve. Okay, very good. So the question was on H. First of all, it's ludicrous for letter G whether they'd all be 90, because of course this would go on to a tetrahedron, and so to get the most space filling, and so this would be, the angles would be about 109.5 since we've no double bonds and no free electrons. The question on H was if we have 4 PO bonds are found to have a bond length of about 162.5, which is roughly 163 picometers. It's got to be diagram 2 because again it shows all single bonds. Now how you would justify that, I'm not fond of this question, because the justification is simply it has all single bonds, so they're all about 162, 163. I think personally, if I had written this problem, I would not have put this table in, because I would have made you know that a double bond is shorter than a single bond, and therefore this one can't have equal bond lengths. Just clicked. Okay, burning ethanol in air, number of moles produced, heat produced. One method of producing ethanol by this reaction, ethane and water are below. Chemist wants to run the reaction and maximize the amount of ethanol. Identify 2 ways the chemist could change the reaction conditions other than adding or removing chemical species to favor the formation of more product. All right, let me go to a desk screen. Okay. So 2 ways to work with this. Let's get the equation itself, get some size on that. All right. All right. All right. So first what I would say is we're starting with a double bonded ethene reacting with water, and they're saying it's at equilibrium to make ethanol. Now, gives us a del H. Del H being negative 45, that indicates that the energy is being produced. We can kind of include it on the product side. So one methodology to change the reaction conditions to get more product. So if we have an exothermic reaction, we want to get more product, we would want to decrease the temperature. If we decrease the temperature, the equilibrium will shift and continue to produce more product. And so if we kept it in a very, very cold space, that would help. Now that's one. What's another? Well, we're not allowed to change the amount of any chemical species. Now, ordinarily what I would say is, given this layout, since they're all gaseous, it wouldn't be easy to simply vent the ethanol or remove the ethanol somehow. The only thing I guess they're fishing for here would be a catalyst. To be honest, I haven't actually watched the answer, so it's been a crazy couple of days. So Avery, besides decreasing temperature, did they go catalyst or did they go something else? Okay. It's good. Why am I not thinking? Because it's in an enclosed container. So the reply Avery gave was to decrease volume. Well, if we've got 3 gaseous species and we basically get it into a smaller space, now what happens is you've got 2 gaseous species on the left, 1 gaseous species on the right. One way to justify that that's a shift is you could look at the initial Kp, which is pressure of ethanol. Ignore that. Handwriting is terrible. Pressure of C2H5OH over the 2 other pressures of the ethene and the water. All right. Now, if you decrease the volume, what's going to happen to the pressures? The pressures are going to increase. So the way you could say that is if you say, okay, quick and dirty justification, you say Q is now 2P of this times 2P of that times 2P of the water. All right, and then you could just break that out and go 2 times 2 over 2 times 2, and then you've still got the same Kp term. And so you say, okay, Q is 1/2 of Kp, therefore it's going to shift towards products. That would be my 1-minute explanation for why it's going to shift in that direction. Does that help? Okay. Let me make that a little larger. Oh. So I'll just leave that up there for a second so people can see that it's clear. I know my handwriting is god-awful this morning, but that helps. That would be a really easy way to support your answer, and given that we're going to be working under a ridiculous time constraint, anything you can do to cut things down and make it happen faster would be huge. Now, while I'm waiting for you guys to come in with another question, please, please, please make sure you're looking at my updates the next day or so. There is a rumor that we may get some sort of synchronous communication. It's not guaranteed yet. It hasn't been approved yet. But if it does get approved, all the stuff will come out hopefully in the next day or two, and we can, for the last few days before the exam, we can have some form of synchronous communication where I could actually go, you know, and pretend we're back where we were 3 or 4 weeks ago when we were Zooming. Yeah, question is if just decreasing pressure is too vague. Yeah, increasing pressure. Yeah, because how do you do that? How do you, what you have to, anything you're going to say about the system is something you have to be able to physically do to the system. You can't physically change pressure. You physically change volume in order to effectively change pressure, because the pressures will adapt and become something different because you decrease the volume. So be really careful how you say that. Make sure you say something that you can actually physically do. Okay, question F. Let's see, let's follow the stream. If you don't mind, I'm going to take a moment and follow the stream through. Lead reacts with chlorine, precipitates KSP of lead phosphate. Using the KSP value and explain why phosphate is more effective than chlorine. Higher concentrations of lead are found in pipes carrying hot rather than cold. Is this observation consistent with the negative enthalpy of dissolution? All right. So let's see what we can do with that one. Okay. Now, Colin, as I'm writing this, one of the things I'm going to say to you, be honest, you're not going to be able to probably get the entire thing done, or you may be, there only may be a few folks who get the whole thing done. So some of you watching this, you may have to simply accept when you see something like this, jump over it and come back. Because if you have to give it more than a minute's thought, you've used up a minute that you may not necessarily have. So, alright, so let's look at that in terms of, so lead going to lead ions, let's say 2+, I believe that's how they were represented, yeah. And now, +2 electrons going somewhere, so this is a half reaction. It says that it's a negative enthalpy of dissolution. So, really? Or are they saying that lead dissolves to make lead aqueous? But in either case, if it's a negative enthalpy of dissolution, then the energy is over here. Is that consistent? Well, if you increase the temperature, that says that the water is hotter. So if this is in equilibrium, which it should be, because obviously not all the lead becomes lead ions as soon as you place them in water, or if they just want lead aqueous, still as a lead metal that's dissolved, definitely not consistent, because basically what we're saying is if the energy is increased, the equilibrium should shift back to the solid lead. So it would, what that would say is, if it's a negative enthalpy of solution, what that would say is that the lead solid plus energy should go to lead aqueous if we observe there to be more dissolved lead in hot pipes. Does that make sense? Yeah, it definitely doesn't jive with a negative energy, or a negative enthalpy. And it actually makes sense in another way, because if the energy is over here, because what you're asking the particles to do is, if you have particles of lead and you're asking them, if you can imagine this in a water solution, you're asking them to leave that stable arrangement, that, one close packing arrangement, and go into a far less ordered arrangement. So you would have to give them energy to get them away from that. And so again, it makes sense that the energy is on the left. Okay, so the question is, letter J, believe that oxygen is further along the group than phosphorus is too vague. Okay, so let's look at J. Let me get this all on one screen. Alright, there we are. Okay, student notices the rightmost piece of oxygen is taller than the rightmost peak of phosphorus. Student claims that this is because oxygen has fewer occupied shells, which means that the valence electrons are closer to the nucleus and experience a greater attraction. Do you agree or disagree? Justify based on data and principles of atomic structure. Alright, so clearly the phosphorus has the extras. Phosphorus is lower overall peaks. Okay, so if we look at where phosphorus and oxygen are in relation to one another on the periodic table, they gave you two that are diagonal from each other instead of simply one beside the other, which gives you two distinct things at which to look. One is, now you've got you've only got P3 as opposed to P4, and the other thing that you've got to deal with is the fact that this is now third energy level versus second energy level. So it says that oxygen is taller than the rightmost peak of P. Okay, so in that particular case, the only thing that we're working on with height, because this is going out from outside in, this is 1s, 2s, 2p, 3s, 3p, this is 1s, 2s, 2p, so the height has absolutely nothing to do with the energy level. The height is because here you have 3 valence electrons and here you have 4 valence electrons. Alright, so further along the group, again, location, I think I said this before we went on break, but location is not justification. Alright, location is not justification. You can't simply look at a periodic table and say this one's further down or further to the left, further to the right, and say that that has some meaning. So you cannot say phosphorus is further to the left, therefore the peak is lower. No. Phosphorus is further to the left because it has only 3 valence electrons, whereas oxygen has 4. Therefore, phosphorus's peak is going to show up as lower because this is representing 1, 2, 3 electrons as opposed to 1, 2, 3, 4 electrons. Okay, so big thing to take away from that one: location is not justification. Please make sure that you're explaining things in terms of the actual physical behaviors. It goes back to what we said earlier today. If you're looking at trying to affect a gas, you can't say, I changed the pressure. I can't physically do that. So make sure you look at what you're actually physically able to control, what's physically actually there in terms. Okay, justification and time constraints are the two difficulties. I would agree exactly with that, Colin. The time constraint's going to be huge. I see them throwing A through J at you on the long one and A through H at you on the short one. The actual proctor, the guy who's in charge of the APs, is saying the exact same thing. You're not going to finish. Not that you might not finish. People on my listservs are saying this is, going to be really, 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 really tough to get it all done. So it's going to be the same thing that I've been teaching you over the last, the last few tests that I was giving you. The way to attack this is to go through, hit a problem. If you can nail it, nail it. If you're not sure about it, move on and come back to it if you have time. But I think the justification piece, that's one of the things that you guys have been working hard on all year. I think you'll be better off than a lot of folks, because a lot of times they just memorize the rule and they haven't really understood why. But I think in most cases on your labs and on your tests you've been forced to explain why, so I think you'll be in okay shape there.